Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 36, valid Sudoku. We're told that we need to determine if a 9 by 9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. So we only need to look at the filled cells in this Sudoku board. Each row must contain the digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. And each of the 9 3x3 sub-boxes of the grid must contain the digits 1 to 9 without repetition. And a Sudoku board partially filled could be valid, but is not necessarily solvable. Only the filled cells need to be validated according to the mentioned rules. So in this example, for example, if we had a 3 here, well, in this third row, well, there is no 3, but if we look at the column, in this third column there is no 3, but if we look at the row, we do see another 3, so this would not be a valid Sudoku board because we've got duplicates. So how can we solve this problem? Well, what we can do is create a hash set for each column and for each row, as well as for each of the 3x3 sub-box, and check if our value is in any of these hash sets. If there's duplicate in any of these hash sets, it means our Sudoku board is not valid. And if it's not, that means we do have a valid Sudoku board. So I'm going to hop straight into the code. Today we're going to be writing this in C#. So how can we solve this problem? Well, let's create a hash sets for the rows, for the columns, and for the boxes or the sub boxes of the grid. So we can say var rows equals new hash set, and we're going to store characters in this hash set, and we want this hash set to be a fixed length of 9, because we know our Sudoku board is a 9 by 9 grid. And we can do the same for cols, and we can do the same for boxes. And let's make sure we don't forget our semicolons as well. So in each of these hash sets, we want hash sets within those hash sets, so that we can basically check for each row, for each column will have their own hash set, so we can check if the duplicates are in those hash sets. So we can say for int I equals 0, as long as I is less than 9, let's keep incrementing I. Okay, and what we want to say now is rows I is going to be equal to a new hash set, and again, this is going to be of chars. So that's going to be our. We can just basically copy and paste this actually. So we can say for cols I and for boxes I. So now we've got a hash set which is made up of hash sets. Fantastic. So what do we do now? Well, now we can actually look for each digit in our Sudoku board. Does it exist in any of the hash sets? And if it does, we return false. If it doesn't, we return true. So I'm just going to copy this actually. For an I, and then we can copy as well for the nested for loop. So, and we're going to change this to R for the row and C for column. Okay, so we know that if we come across just a full stop, then or period, we basically this is an empty cell, so we don't need to do anything with empty cells. So we can just say if, well, actually, we're going to be using board RC a lot, so let's just say value is going to be the value of the digit at the row and column that we've got. Okay, so this saves us some typing time. So if the value equals a period, then we just continue, because we don't need to do anything now. Then we want to check if rows are dot includes, or actually it's going to be dot contains value. Well, then we can return false. The same for columns and the same for boxes. So if cols c dot includes the value, we'll find a duplicate in one of the columns. And for boxes, well, now for boxes, it's just a tad bit tricky because we have a 9x9 grid, but each of these boxes is a 3x3 each is 3x3 sub box. So we have 3 sub boxes, and a 3x3. We have 9 sub boxes in total. So that's basically what we need to do to find out which sub box our value is in, is by dividing the index of that cell by 3, by basically doing integer division. So we can say R divided by divided by 3, like this, integer division times by 3 plus C divided by 3 again, and this will give us the correct box and the correct hash set for our sub box. And then we can now return false if we find a duplicate. If we don't find a duplicate, we can say rows dot add value cols c dot add value, rows r dot add value, and then boxes, and then again copy this logic over here. This is going to be our box index, and we're going to add the values if we don't return false. And if we finish our for loops, should I say, without returning false, then we know that our Sudoku board is valid. So then we can just return true. So let's check our code works. And expected, okay. Oh, I guess we shouldn't have put that there. Type or namespace cannot be found. Type or namespace chars could not be found. Oh, I see. Char, not chars. Let's check again. The value does not exist in the means to put a var value. Okay, and we passed all 507 test cases after 3 little hiccups. So I hope you guys enjoyed this video. In terms of time complexity, it's going to be O of 1. It's going to be constant time and constant space. So O of 1, space and time complexity. And yeah, I hope you guys enjoyed this video, and I'll catch you in the next one.